Hi, all. Very happy morning to each and every one. Very happy morning to everyone. Yesterday night we discussed a calendar session number 1. In calendar session number 1, we discussed a lot of concepts related to how to find whether an year is a leap year or a non leap year, how to find the number of extra days in 100 years, 200 years, 300 years, 400 years. And we discussed another very important key point. The last day of a century can never be Tuesday, Thursday, or Saturday. Now we will do some more interesting problems on calendar session number 2. Calendar session number 2. I hope the audio it is clear. I hope there are no issues with audio. I hope there are no issues with streaming issues. Kindly reply it in the live chat present in your live classes side heading. No buffering issues. Another 1 hour of time we will spend on calendars. Before I start the class, let me cross check if everything is clear. I hope you all got the notification. Calendars session number 2. I hope there are no issues. Let me check it out. Calendar session number 2. In calendar session number 1, let me do a recap of what are all the concepts that we discussed in calendar session number 1, so that we will do a recap in session number 2. In calendar session number 1, in calendars session number 1, these are some of the concepts which we discussed in calendar session number 1. A leap year. I'm just doing a repetition of some important key points which we discussed yesterday night, so that when you are watching this class you will not get a single doubt. First key point is a leap year. A leap year will have 366 days. A leap year has 366 days, which will have 52 weeks plus extra 2 days. 52 weeks plus extra 2 days. A leap year will have 2 extra days. Suppose if I take a non-leap year, if I take a non-leap year will have 365 days. A non-leap year will have 365 days. There are 7 days in a week. So 52 weeks plus 1 extra day. 52 weeks plus 1 extra day. A leap year will have 2 extra days and a non-leap year will have 1 extra day. Based on this, what is the second key point that we discussed? 100 years. 100 years will have how many extra days? 5 extra days. In case if you are watching this class, if you have not seen session number 1, I would strongly recommend you to go out and watch session number 1, then watch session number 2. Then you will understand this concept in detail. 100 years will have 5 extra days. 200 years will have 3 extra days. 200 years will have 3 extra days. 300 years will have 1 extra day. 300 years will have 1 extra day, and 400 years will have 0 extra days. 400 years will have 0 extra days. We have determined yesterday in 100 years there will be 24 leap years and 76 non-leap years. Wherever leap year is there, I took extra 2 days. Wherever non-leap year is there, I took extra 1 day. 100 years has 5 extra days, 200 years 3 extra days, 300 years 1 extra day, 400 years 0 extra day. What is then another third key point that we discussed? Last day of a century. Last day of a century can never be. Last day of a century can never be Tuesday, Thursday or Saturday. A last day of a century can never be Tuesday, Thursday or Saturday. A century last day can never be Tuesday, Thursday or Saturday because 100 years have got 5 extra days. That means the last day of 100th year code value will be 5. Last day of 200th year code value will be 3. Last day of 300th year code value will be 1 and 400 years code value will be 0. How you got this? By taking Sunday as 0, Monday as 1, Tuesday as 2, Wednesday as 3, Thursday as 4, Friday 5 and Saturday 6. Friday 5 and Saturday 6. That means we got 5 is Friday, we got 3 which is Wednesday, 1 is Monday and 0 is Sunday. What are all the values which are not possible? Tuesday it is not possible, Thursday it is not possible and Saturday it is not possible. Saturday it is not possible. Now what is the fourth concept that we discussed yesterday? A repetition of a calendar. Repetition of a calendar. In these repetition of a calendar, we just did it for a non-leap year. In a non-leap year, what do you mean by a non-leap year? A non-leap year is an year which is never divisible by 4. If it is never divisible by 4, either it gives a remainder 1 or it gives a remainder 2 or it gives a remainder 3. When you divide a number by 4, remainder is 0. That means it is perfectly divisible. So if it is not divisible by 4, either it gives a remainder 1 or remainder 2 or remainder 3. Remainder 1, the calendar will repeat after 6 years. Calendar will repeat after 6 years. Remainder 2, remainder 3, the calendar will repeat after 11 years. Calendar will repeat after 11 years. If the given year is a non-leap year, calendar repetition will happen for after 6 years if it gives a remainder 1, after 11 years if it gives a remainder 2 or 3. Very easy to remember. Remember World Trade Center collapse 9 by 11. 9 ulta kar do, 6 by 11. 6 and 11. Very important. Otherwise, you will waste your time in counting it. Very easy concept, straightforward concept. If it gives a remainder 1, the calendar will repeat after 6 years. If it gives a remainder 2, the calendar will repeat after 11 years. Remainder 3 also, calendar will repeat after 11 years. Now, what will happen if the given year is a leap year? We will see it. These were some of the concepts yesterday we discussed in calendars session number 1. Calendar session number 1, these were the concepts which we discussed. Now, what will happen if it is a leap year? Please write down, sir. Very important point. If the given year is a leap year, if the given year is a leap year, if the given year is a leap year, calendar will repeat. If the given year is a leap year, calendar will repeat. Calendar will repeat after every 28 years. If the given year is a leap year, calendar will repeat after every 28 years. For every 28 years after, calendar will get repeated. Sir, are there any exceptions to this condition? Yes, exception. First exception. If the given year is a leap year, if the given year is a leap year and it crosses a century, which is not a leap year, and it crosses a century which is not a leap year. How to check whether a century is a leap year or not? A century should be divisible by 400. If the given year is a leap year and it crosses a century which is a non-leap year, and it crosses a century which is a non-leap year, then calendar will repeat. Then calendar will repeat after every 12 years. Then calendar will repeat after every 12 years. Very, very important key point. Very, very important key point. If the given year is a leap year, calendar by default it will repeat after every 28 years. In case if it is encountering a century which is a non-leap year, then the calendar will repeat after every 2 years. Then the calendar will repeat after every 12 years. Yesterday we discussed a very, very important key point. What is the key point? If the given year is a leap year, answer will be a leap year. If the given year is a leap year, answer will be a leap year. If the given year is a non-leap year, answer will be a non-leap year. A leap year calendar will match with another leap year. A non-leap year calendar will match with another non-leap year calendar. Another non-leap year calendar. Another non-leap year calendar. If the given year is a leap year, if the given year is a leap year, calendar will repeat after every 28 years. Calendar will repeat after every 28 years. Under a case, then it will be 12 years. Under a case, then it will be a 12 years. I hope the idea it is clear. Right? We will do a lot of examples. Then you will understand what are all the various ways of using this. This concept is clear. Non-leap year means which will be never be divisible by 4. If it is never divisible by 4, it gives a remainder 1, it gives a remainder 2, it gives a remainder 3. Remainder 1, it is plus 6 years. If it is remainder 2, remainder 3, it is plus 11 years. If it is a leap year, calendar will repeat after every 28 years. Under a case, then it will be 12 years. One by one, we will solve a problem. Questions. Questions based on the key point number 5. First one, calendar repetition. Calendar repetition. Let us do one by one. Calendar repetition. First question. Suppose if I take 2024, calendar will repeat immediately after how many years? 2024. Calendar for 2024 will repeat after which year? 2024 is a leap year. 2024 is a leap year. Because it is a leap year, it will repeat after 28 years. After 28 years. Answer is 2052. Answer is 2052. Idea clear? Second one. Calendar for 1948. Calendar for 1948 is it crossing a century which is a non-leap year? No. So it will repeat after 28 years. After 28 years will be 1948 plus 28. Answer is 1976. Third one. Listen carefully, sir. Calendar for 1896. Calendar for 1896. We will do traditional method, then we will do an optimal method. Why plus 12 is coming? Let us see it. Traditional method. How to check the calendar repetition related problems? 1896. 1896 is a leap year. A leap year will have 2 extra days. A leap year will have 2 extra days, and a non-leap year will have 1 extra day. A leap year will have 2 extra days, and a non-leap year will have 1 extra day. A non-leap year will have 1 extra day. We'll use this concept. 1896 is a leap year, so it will have 2 extra days. 97 is a non-leap year, it will have 1 extra day. 98 will be a non-leap year, so it will have 1 extra day. 99 will be a non-leap year, it will have 1 extra day. 1900 is a century. Century is never divisible by 400, so it will be 1. 1901 is a non-leap year, so it will have 1 extra day. How much we got? 2 plus 1 3, 3 plus 1 4, 5, 6, 7. Don't hurriedly tick mark the answer as 1902. 1902 is incorrect. Why? Because the given year is a leap year. If the given year is a leap year, answer should also be a leap year. 1902 is not a leap year. Therefore, 1902 will not be the answer. 1902, it is 1. 1903, it is 1. 1904, it is 2. 1905, it is also a non-leap year, it is 1. 1906, it is 1. 1907, it is 1. See here, till here, sum is 1 plus 1, 2, 2 plus 1, 3, 4, 5, 5 plus 2, 7. But 1902 is not a leap year, so I continued. 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 1, 6, 6 plus 1, 7, 7. The next year is 1908. The next year is 1908. Exactly this is what I told it in the previous slide. If the given year is a, what is the previous slide? If the given year is a, please see here. If the given year is a leap year, if the given year is a leap year and it crosses a century, and it crosses a century, which is a non-leap year, calendar will repeat after 12 years. Calendar will repeat after 12 years. The given year is a leap year. Given year is a leap year. It crosses a century, 1900, which is a non-leap year. It crosses a century, which is a non-leap year. So the calendar will repeat after every 12 years. After every 12 years. I hope the idea it is clear. Another concept, don't forget. If the given year is a leap year, answer will also be a leap year. If the given year is a leap year, answer should also be a leap year. If the given year is a non-leap year, if the given year is a non-leap year, answer will also be a non-leap year. So 6 and 11 are the code values if the given year is a non-leap year. If the given year is a leap year, calendar will repeat after 28 years or after 12 years. Calendar will repeat after 28 years or after 12 years. Now let us see one more example. Suppose, for example, 1592 it is there. 1592. 1592. Is it crossing a century? Definitely yes. 1600. Is it a leap year? Yes. 1600 is divisible by 400. So answer will be directly plus 28. Directly it is plus 28. So these 1620. 1620. Only in an exception it will be plus 12 years. What is an exception? Exception is if the given year is a leap year and it crosses a century, which is a non-leap year. If the given year is a leap year and it crosses a century, which is a non-leap year, then only it is plus 12. Fourth one, I hope the idea it is clear. Now let us do 1788. Please put a star mark on this question. 1788. Why star mark? Because a beautiful learning will happen from this question. 1788. Given year, it is a leap year. Given year, it is a leap year. Now, it is going forward meeting a century. Meeting a century is 1800. 1800 is a century. But is it divisible by 400? 1800 is not divisible by 400. So it is a non-leap year. Should I do plus 12? Suppose if I do plus 12. If I do plus 12, I will get the answer 1800. I will get the answer 1800. 1788. Last two digits are 88. That means it is a leap year. 1800 is not divisible by 400. It will become a non-leap year. It will become a non-leap year. It will become a non-leap year. Are you all with me? Can a leap year calendar match with a non-leap year calendar? Can a leap year calendar match with a non-leap year calendar? No. Therefore, answer will not be 1800. Please make a note, sir. Answer will not be 1800 for the simple reason 1788. 1788, it is a leap year and it crosses a century which is a non-leap year. So should we do plus 12? If I do plus 12, I am getting the answer 1800. 1788. 88 is divisible by 4. 1800, it is a century which is not divisible by 400. So what will be the answer? Very, very good question, sir. What will be the answer? Let us go by the traditional method. 1788. 88, it is a leap year. Leap year has extra 2 days. Non-leap year has extra 1 day. Leap year, non-leap year has extra 1 day. Non-leap year has extra 1 day. 92, it is divisible by 4. So leap year has extra 2 days. 2 plus 2, 4. 4 plus 3, 7. 7 out. Next it is 93. 93, it is a non-leap year. A leap year calendar should match with a non-leap year calendar. 93, it is 1. 94, it is 1. Are you all with me? 95, it is 1. 96, it is 2. 97, it is 1. 98, it is 1. 98, it is 1. 1 plus 1 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. There are 7 days in a week. Next one, it is 1799. 88, it is a leap year. Answer should match with another leap year, non-leap year, 1 extra day. 1800, it is also a non-leap year, 1 extra day. 01, it is 1 extra day. 02, 1 extra day. 03, 1 extra day. 04, 2 extra days. 1 plus 1 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. Next it is 1805. Is 1805 a leap year? No. Continue it. 1805. Here exactly some 7 came. 2 plus 2, 4. 4 plus 3, 7. Here also 2, 3, 5, 6, 7. Here also 7 came. 1, 2, 3, 4, 5, 7. Here also 7 came. 1805, non-leap year 1. 1806, non-leap year 1. 1807, non-leap year 1. 1808, it is leap year 2. 1802, 9, 1. 1810, 1. 3 plus 2, 5. 5 plus 2, 7. So there are 7 days in a week. 1810. Next answer is 1811. 1811. It is a leap year? No. So continue it. 1811. 1811. It is 1. 1812. It is 2. 1803, it is 1. 1814, 1. 1815, 1. 1 plus 2, 3. 3 plus 3, 6. 1816, 2. 1817, 1. 1818, 1. 1819, 1. 1820. It is 2. Let us take the sum. 1 plus 2, 3, 4, 5, 6, 8, 9, 10, 11, 13, 21, it is 1. Here also it is 14. Suppose if I take 1822, it is 1. 23, it is 1. 24, it is 2. 25, it is 1. 26, it is 1. 27, it is 1. Now see here. 1 plus 1, 2. 2 plus 2, 4. 5, 6, 7. It is 1828. Answer for this question is 1828. Sir, should I go ahead and use this traditional method? No. I will tell you in a table very clearly in the next slide, which will help you to analyze it. 1788. Don't do this mistake. 1788, it is a leap year. If it is crossing a century, which is a non-leap year, check with plus 12. The given basic definition should not get violated. What is the basic definition? Given year is a leap year, answer will be a leap year. Given year is a non-leap year, answer will be a non-leap year. Now, listen carefully to these concepts. Listen carefully to this concept. Very, very important slide. If you understand this slide, then answer will be very easy. Repetition of calendars. Very, very important concept. Repetition of calendars. Repetition of calendars. There are two things. A year will be given to you. If an year is given to you, there are two cases. One is it will be a non-leap year. One will be it will be a non-leap year. If it is a non-leap year, if it is a non-leap year, it will have a remainder plus 1. It will have a remainder plus 2. It will have a remainder plus 3. So if it is plus 1, the calendar will repeat after 6 years. If it is plus 2, calendar will repeat after 11 years. If it is plus 3, calendar will repeat after 11 years. If it is a leap year, if it is a leap year, then these three cases will come. By default, it is plus 28 years. By default, it is plus 28 years, and it will be plus 12 years. It will be plus 12 years if it is crossing a century. If it is crossing a century, which is a non-leap year. If it is crossing a century, which is a non-leap year, then it will be plus 12. Under which case there will be plus 40? Plus 40 is this case. What is this case? Given year is a leap year and it crossing a century, which is not a leap year. If I add it, question is a leap year, answer should also be a leap year. Question is a non-leap year, answer should also be a non-leap year. So plus 40 will come to make the given question leap year and an answer leap year. I hope the idea it is clear. One by one we will solve. If the given year it is a non-leap year, if it gives a remainder 1, calendar will repeat after 6 years. If it gives a remainder 2, calendar will repeat after 11 years. If it gives a remainder 3, calendar will repeat after 11 years. By default, if the given year is a leap year, and calendar will repeat after 28 years. In a case where it is crossing a century, which is a non-leap year, then it will be plus 12 years. Given year should be a leap year, answer should also be a leap year. Given year should be a leap year, answer should also be a leap year. If that condition is violated, then it is 40. Repetition of calendar works with plus 6 years or plus 11 years or plus 12 years or plus 28 years or plus 40 years. Plus 6 plus 11 plus 12 plus 28 plus 40. I hope the concept is very, very clear to you. Only there are two kinds of questions that will come in your examination. The given year can be a leap year or the given year can be a non-leap year. If it is a non-leap year, it is plus 6 or plus 11. If the given year it is a leap year, it will be plus 28 years by default. If it crosses a century, then it is plus 12 years or otherwise it is plus 40 years. Otherwise it is plus 40 years. Questions we will do. Practice questions. The calendar for 1968 will repeat after how many years? Is it crossing a century, which is a non-leap year? No. Answer is plus 28. Answer is 1996. Answer will be 1996. Second one. The calendar for example, 1692 it is there. 1692. Is it crossing a century? Yes, 1700. Is it a leap year? It is a non-leap year. It is a non-leap year. So the calendar will repeat after how many years? It is after 12 years. So these will become 1704. This will become 1704. I hope the idea it is clear, right? For example, 17. Suppose for example 1772 I am taking. 1772 I am taking. Listen carefully, sir. These are all some interesting questions. 1772. If I take plus 28, this will become 1800. This will become 1800. Is 1800 a non-leap year? 1800 is not a leap year. 1800, it is not a leap year. Now, should we take plus 28 or should we take plus 12? Should we take plus 28 or should we take plus 12? So if I take plus 28, 28 plus 12, 40. 40 will be 1812. 40 will be 1812. 1812. 1772. I hope the idea it is clear. Given input, it is a leap year. But if I do plus 28, I am getting 1800. 1800, it is a non-leap year. So should I do plus 28 or plus 12? What we will do is, just to ensure that you get 100% concept, I will do it in a traditional method. 72 leap year, it is 2. 73 non-leap year, 1. 74 non-leap year, 1. 75 non-leap year, 1. 76 leap year, 2. Leap year 2. 2 plus 2, 4. 4 plus 3, 7. Next one, 77 non-leap year, 1. 78 non-leap year, 1. 79 non-leap year, 1. 80 leap year, it is 2. 81 non-leap year, 1. 82 non-leap year, 1. 1 plus 1 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. I hope it is clear. Next one, if I take 83, it will be 1. 84, it will be 2. 85, it will be 1. 86, it is 1. And 87, it is 1. 88, it is a leap year 2. 1 plus 2, 3. 3 plus 3, 6. 6 plus 2, 8. 8 over 89, it is 1. 90, it is 1. 91, it is 1. 92, it is 2. 93, it is 1. 94, it is 1. 1 plus 2, 3, 4, 5, 6, 8, 9, 10, 11, 13, 14. 93, 94 1, 95 1, 96 2, 97 1, 98 1 and 99 1. See here, 2, 4, 5, 6, 7. So we got 1800, but 1800 is not a leap year because a century should be divisible by 400. 1800 is not divisible by 400. So I will prolong 1800. 1800, it is a non-leap year 1. 1801, 1. 1802, 1. 1803, 1. 1804, 2. 1805, 1. 2, 3, 4, 6, 7. 1805, there are 7 days. 1806, it is a non-leap year. Continue it. 1806, it is 1. 1807, 1. 1808, 2. 1809, 1. 1810, 1. 1811, 1. 1 plus 1, 2. 2 plus 2, 4. 5, 6, 7. Next it is 1812. 1812. 1812 we got because of plus 28 and plus 12. That is exactly what am I specifying in the previous slide, this concept. This previous slide. If the given year is a leap year, calendar will repeat exactly after 28 years, except when it crosses a century, which is a non-leap year. It is plus 12. If any condition is violated, what are the conditions violation? If the given year is a leap year, answer will be a leap year. If the given year is a non-leap year, answer will be a non-leap year. If any such condition is violated, then it will be plus 40. Then it will be plus 40. I hope the concept is clear. I am sure you will not get a single doubt in this one. The given year is a leap year. It does not cross a century. By default, it is 28 years. Very, very easy to remember. There are 7 days in a week, and the leap year, if it is non-century, it will come once in every 4 years. 7 into 4 is 28. I hope the concept is clear. Calendar repetition, it is plus 6 plus 11 plus 12 plus 28 plus 40. Plus 6 plus 11 plus 20, 12 plus 28 and plus 40. Idea it is clear, right? Next concept. Next concept. I made a statement. Leap year comes in every 4 years if the given year it is a century. Now very, very good question, sir. What is the minimum number of days? What is the minimum number of days in 5 consecutive calendar years? What is the minimum number of days in 5 consecutive calendar years? Minimum number of days in 5 consecutive calendar years. 5 consecutive calendar years. Now see here, sir. Very, very good question. It will give a very interesting lesson. What is the minimum number of days in 5 consecutive calendar years? Most of the students will do a mistake. This is year 1. It is year 2. Next it is year 3. Year 4, year 5. Most of the students will think that leap year comes in every 4 years. Leap year comes, so definitely it, and they will do the answer. Leap year comes in every 4 years, so we want minimum. So 4 non-leap years will be there and 1 leap year they will do it. 365 into 4 plus 366 they will do it. If they calculate it, they will tick mark the answer as 1826. But 1826 is incorrect. Why? Because if I take 1897, it is a non-leap year. It is a non-leap year. 1898, it is also a non-leap year. It is also a non-leap year. 1899, it is also a non-leap year. 1900, it is also a non-leap year. It is also a non-leap year. 1901, it is also a non-leap year. It is also a non-leap year. That means what we have studied till now, leap year comes in every 4 years. That is right if there is no century in between, which is not a leap year. We please write down that very, very important concept. Leap year comes in every 4 years. Leap year comes in every 4 years. This statement is definitely right. Leap year comes in every 4 years only if all the years are non-century years. Only if all the years are non-century years. Only if all the years are non-century years, then only leap year comes in every 4 years. Leap year comes in every 4 years only if all the years are non-century years. Only if all the years are non-century years. I hope the concept is very, very clear to you. If anybody asks you, leap year comes once in every 4 years, you should say definitely right. Only if it is all the years that are given are non-century years. Here I got a century. Century. If it is a non-leap year, then I am getting the answer. Non-leap year, non-leap year, non-leap year, non-leap year, non-leap year. Is leap year coming once in every 4 years? No. What is the answer for this question? 365 into 5. 365 into 5 is 1825. 365 into 5 is 1825. I hope the concept is very, very clear to you. Leap year comes in every 4 years if the given years are non-century years. If one of the year, if it is a century, then it might result in, right, all the years could be a non-leap years. Very, very good question, sir. Extremely interesting question. Otherwise you will do a calculation mistake in this question. Calculation mistake in this question. I hope the idea it is clear. So we did calendar repetition related problems. Last day of a century can never be Tuesday, Thursday or Saturday. Another one. How to find the day of a given date. How to find the day of any given date. 3 problems we'll solve, which will give a very good understanding of how to use the concept of how to find the day of any given date. Any given date. How to find the day of any given date. These can be solved in 3 methods. Method number 1. Method number 1 is by using odd days concept. Method number 1 is by using odd days concept. Method number 2 is Method number 2 is by using a beautiful rule which we call it as Zeller's rule. Method 2 is Zeller's rule, and method 3 is key value method. Method 3 is key value method. You take any method, you will get the answer. Method 3 is key value method. By using any of these methods, you will get the answer. In case if you are not good in remembering formulas, there is a non-formulae method. Zeller's rule. This is a formulaic approach. There is a formula to find the day of any given date. Formulae method. From these formulae method, method 3 is a derived method. All the three concepts we will try to see if we can complete in the morning session. Otherwise, we will get into the another session. We will do the key method. How to find the day of any given date. How to find the day of any given date? There are three ways to solve. Method 1 is by using odd days. Method 2 is by using Zeller's rule. And method 3 is by using derived method. Method 1, let us discuss. Method 1. What is method 1? Odd days method. In these odd days method, we require some inputs. Based on the inputs, we will solve it. Odd days method. What are the inputs? A leap year has 366 days. It will have 2 extra days. 52 into 7 plus 2. A non-leap year has 365 days. 52 into 7 plus 1. 1 extra day. A non-leap year will have 1 extra day. What is the another concept that we discussed? 100 years will have how many extra days? 5 extra days. 200 years will have 10 divided by 7. 3 extra days. 300 years will have 15 divided by 7. 1 extra day. And 400 years will have 0 extra days. All these concepts related to odd days, we are going to use it. How to find the day of any given date? One is by using odd days concept. To use odd days concept, we require leap year has 366 days. 2 extra days. Non-leap year has 365 days, 1 extra day. 100 years will have 5 extra days. 200 years will have 3 extra days. 300 years will have 1 extra day. And 400 years will have 0 extra days. We will use these 3 important key points to find out the day of any given date using odd days method. I hope the concept is clear. Now let us see. First one, 15th August 1947. 15th August 1947. 3 problems I will solve which will give a very good understanding of how to find the day of any given date. Solution. 15th August. Right from the day Gregorian proposed the calendar, first 1900 years are over. 1900 years are over. Then 46 years are over. 1946 years are over. I entered into 1947. We need 15th August. January has 31 days. February 1947 is a non-leap year. Non-leap year will have 28 days. March will have 31 days. April will have 30 days. May will have 31 days. June, it will have 30 days. June will have 30 days. July will have 31 days. I want August. Which date I want? 15th August I want. 15th August, 15 I want. First 1900 years are over, then 46 years are over. January 31 days. February it is a non-leap year 28 days. March 31 days. April 30 days. May 31 days. June 30 days. July 31 days. We all know, our parents have taught how to count the number of days like this. January, February, March, April, May, June, July, August, September and October. I hope this idea it is clear. Now we will not use these high values. We will reduce these values. 1900 years will become 4 into 400 plus 300. Are you all with me? 46 years. 46 years. What are all the leap years? 4 is a leap year. 8 is a leap year. 12 is a leap year. 44 is a leap year. So totally 46 divided by 4. 11 leap years are there. Remaining it will be 35 non-leap years. 35 non-leap years. January 31, 7 4s are 28, remainder 3. February 28 divided by 7, 7 4s are 28, remainder 0. How we are getting 3? 31 I am dividing by 7, 7 4s are 28, 3. 28 divided by 7, 7 4s are 28, remainder 0. March 31 it is 3. April 30 it is 2. May 31, 7 4s are 28, 3. June 30 it is 2. July 31 it is 3. August 15th August I require 15 divided by 7. 7 2s are 14, remainder 1. Is this clear? 1900 years. 4 into 400 plus 300. Why we took 4 into 400 plus 300? 400 will have a value 0. 100 years will have extra 5 days. 200 years will have extra 3 days. 300 years will have extra 1 day. 400 years 0. So 400 it is 0. 300 15, which is 1. Leap year will have extra 2 days. Non-leap year will have extra 1 day. Non-leap year will have extra 1 day. Delete the digits whose sum is either 7 or a multiples of 7, because anyway we are dividing it by 7. 3 plus 3, 6, 9, 12, 14 out. Remaining 2 plus 1, 3. This will become 1 plus 22 plus 35 plus 3. Delete the digits whose sum is multiples of 7. I got 26. 26 divided by 7. 7 3s are 21. It is 5. Remainder it is 5. Sunday will be 0. Monday will be 1. Tuesday will be 2. Wednesday it is 3. Thursday it will be 4. Friday it is 5. We got Independence Day on Friday. We got Independence Day on Friday. Very, very easy counting method. All you have to do is just go step by step. The current year is 15th August 1947. First 1900 years are over. Then 46 years are over. I entered into 1947th year. January 31 days. February it is a non-leap year, so 28 days. March 31 days. April 30 days. May 31 days, June 30 days, July 31 days, August 15th August is what we require. 1900 is written as 4 into 400 plus 300. In 46 years, how many leap years are there? 11 leap years. How many non-leap years are there? 35 non-leap years. January, divide all these by 7, because there are 7 days in a week. 7 4s are 28, 3. 28 by 7, 0. 31 by 7, 3. 30 by 7, 2. 31 by 7, 3. June 30 days, July 31, August 15, 15 divided by 7. Then it is just a calculation. I hope the idea it is clear. This is by using an odd days concept. Let me do one more question. Republic Day. 26th January 1950. 26th January 1950. Let us do 2nd April. Today is 2nd only, right? 2nd April 2021. 2nd April 2021. Let us solve these two practice questions so that these odd days concept will be crystal clear to you. 26th January 1950. First one, 1950. First 1900 years are over. Then 49 years are over. Now I reached January. January 26th January I require. 26th January. 1900 is 4 into 400 plus 300. 49. Leap year comes in every 4 years. 49 by 4, 12. 12 leap years plus 37 non-leap years. 37 non-leap years. 26 divided by 7. 7 3s are 21. Remainder 5. 400, 0 into anything, 0. 100 is 5. 300 will be 15. 15 divided by 7, 1. Leap year will have extra 2 days. Leap year will have extra 2 days. Non-leap year will have extra 1 day plus 5. 1 plus 24 plus 37 plus 5. 37 plus 5. 37 plus 5, 42. It is divisible by 7. 24 plus 1, 25. 25 divided by 7. 25 divided by 7. 7 3s are 21. What is the remainder? 4. What is the concept that we discussed? Sunday 0, Monday 1, Tuesday 2, Wednesday 3, and Thursday 4. And Thursday 4. So we got Republic on Thursday. We got Republic on Thursday. One way to find out the number of which day a particular date belongs, that is by using odd days concept. We have got two more methods to solve the question. We can use Zeller's rule or we can use a key value method, that also will solve. 2nd April 2021. 2000 years are over. Then 20 years are over. Then I got into 2021. January 31 days, 3. 21, it is a non-leap year. So 28 by 7, 0. March 31, it is 3. April, it is 2nd April. I hope it is clear. So 2000 can be written as 5 into 400. 20 can be written as 5 leap years plus 15 non-leap years. 15 non-leap years. 3 plus 3, 6. 6 plus 2, 8. 5, 400, it is 0. Leap year will have extra 2 days. Non-leap year will have extra 1 day plus 8. This will have 10 plus 15 plus 8. So this will be 33. 33 divided by 7. 7 4s are 28, it is 5. 28, it is 5. Thursday is 4, 5 will be Friday. 5 will be Friday. I hope the concept is crystal clear to you. 0 plus 10 plus 15 into 1 plus 8. What are all the important things that you should know? A leap year will have extra 2 days and a non-leap year will have extra 1 day. Whenever certain years are over, 100 years will have 5 extra days. 200 years will have 3 extra days. 10 divided by 7, it is 3. 300 years will have 1 extra day and 400 years will have 0 odd days. I hope you can solve a lot of questions based upon these concept of odd days. Idea it is clear. Now what is this method 2? Method 2. Method 2. There is a famous mathematician by name Zeller. He proposed a formula to find the day of any given date. Any given date. There is a formula that can be used to find the day of any given date. What is this formula method? Let us see. Formula method. Formula method. The formula goes like this. Day equivalent to date plus He has worked for a lot of years to develop these formulae. 13m minus 1 by 5 plus d by 4 plus d by 4 plus m by 4 minus 2 into m minus 2 into m. Again I am repeating, day equivalent to date plus 13m minus 1 by 5 plus d by 4 plus m by 4 minus 2 into m. M represents the month key value. M represents the month key value. What is the biggest problem? Which month is the biggest problem in terms of odd days? February month. If it is a non-leap year, it will have 28 days. If it is a leap year, it will have 29 days. To erase that confusion, Zeller's calendar starts with March. Zeller's calendar starts with March. If I start with January, there are a lot of cases that I am getting in the month of February. 28 days I will get a case, 29 days I will get a case. I don't want to work with multiple cases. So Zeller's calendar starts with March. Zeller's calendar starts with March. Zeller's calendar starts with March. Month key value. That means March month key value will be 1. April month key value, it will be 2. May month key value, it will be 3. Are you all with me? And so on. December month key value, it will be 10. January month key value, it will be 11. February month key value, it will be 12. Zeller's calendar always starts with March. Zeller's calendar always starts with March. Why he started with March? Because if I take January, there will be sub cases in the month of February, right? Zeller's calendar starts with March. Month key value. March month key value, it will be 1. April month key value, it will be 2. May month key value, it will be 3. February month key value, it will be 12. D. Capital D represents the last 2 digits of the year. Capital D represents the last 2 digits of the year. Capital D represents the last 2 digits of the year. Capital M represents the first 2 digits of the year. Capital M represents the first 2 digits of the year. Once you understand this, then it's a very easy substitution. Capital D represents the last 2 digits of the year, and M represents the first 2 digits of the year. Here and here and here. If you get any decimals, please ignore the decimals. Completely ignore the decimal values. 13.1, it is 13. 13.99, it is also 13. Completely ignore the decimal values. It is D by 4. Even if you get 10.99, just remove everything after dot. Even if you get 5.01111 after dot, ignore anything. Ignore the decimals. This is nothing but a greatest integer function from a mathematical point of view. Listen carefully. Another 3 examples I will solve, which will give a very clear understanding of how to use a Zeller's formula. Zeller's calendar starts with March. Zeller's calendar starts with March. First question. Zeller's calendar starts with March. Is this idea it is clear? Zeller's calendar starts with March. Now, 1 minute. I will take this date. Zeller's calendar. First one, it is 15th August 1947. 15th August 1947. Zeller's approach. Zeller's approach. One by one we will go. Zeller's approach. What is a Zeller's approach? Step number 1. Day equivalent to date plus. It is 15 plus. August. March is 1. March will be 1. See here, sir. March is 1. March is 1. April is 2. May is 3. June is 4. July is 5. August will be 6. So this will be 13 into 6 minus 1 divided by 5. Are you all with me? So March will be, that means in Zeller's calendar, it is the 6th month under progression. March is 1, April is 2, May will be 3, June is 4, July will be 5, August will be 6, August will be 6, August key value it is 6, plus D. D is the last two digits. The current year it is in progression, it is 47. D plus D by 4. D by 4. M represents the first two digits. M by 4. 19 by 4. Minus 2 into M. Minus 2 into M. Day equivalent to date plus 13M minus 1 by 5 plus D by 4 plus M by 4 minus 2 into M. That is 15. 78 minus 1, 77 by 5, 77 by 5. These 47. 4, 11s are 44 point something, ignore the decimals, plus 11. 4 point something, ignore the decimals, minus 2 19s are 38. 2 19s are 38. 15. 5 15s are 75 point something. These 47 plus 11, 58. 58 plus 4, 62. 62 minus 38, 24. So this will be 7 2s are 14, remainder 1. 7 2s are 14, remainder 1. 7 3s are 21, remainder 3. 1 plus 1 plus 3, 5. 5 is defined as Friday. Sunday is 0, Monday is 1, Tuesday it is 2, Wednesday 3, Thursday 4 and Friday 5. I hope the idea it is clear. Why we got 6 here? Zeller's calendar starts with March. Zeller's calendar starts with March. March is 1, April is 2, May will be 3, June will be 4, July it is 5 and August it is 6. The only thing you have to be very extra careful in this kind of questions. Suppose if the question is 28th February, 28th January, let us take 1968. 28th January 1968. Day equivalent to date. Date is 28. January, March it is 1. January is the 11th month. That is what we did it. January it is the 11th month. 11th month of which year it is under progression? The 67th year it is under progression. It is 13 into 11 minus 1 by 5. D. D it is the last two digits of the. It is not 68. 68 starts with March. So it is 67. This will be 67 by 4. Are you all with me? Why I wrote 67? Why? Because it is the 11th month of the previous year. Then it will be M by 4. 19 by 4 minus 2 into 19. Here be very careful in terms of writing it. January is the first month for us, but for Zeller January is the 11th month of the previous year. Previous year it is 67. 28 it is 0. 143 minus 1, 142. It is 28. It is also 0. 67. 7 9s are 63. It is 4. 4 16s are 64. It is 16 point something. 19 by 4. 4 point something. Minus 38. Minus 38. So this will be 20, 24. It is minus 14. 14 is 0. So this will be Sunday. This will be Sunday. I hope it is very clear to you how to use Zeller's rule. The silly mistakes which you might do is taking 68 here. Zeller's calendar starts with March. To erase any confusion related to should I take February 28, 29, he started his calendar with March. March month key value it is 1, April 2, May 3, June 4, July 5 and August 6. This is the date 15th August 1947. One example 28th January 1968. Two methods. I hope the concept is very, very clear to you. We will discuss the key value method in our next class. All the concepts are clear, right? How to find the day of these. Method 1 we discussed and method 2 we discussed. Key value method we are going to discuss in the next one. So if it is a leap year, calendar will repeat after every 28 years. If it crosses a century, which is a non-leap year, it will repeat after 12 years. The given year is a leap year, answer should be a leap year. If the given year is a non-leap year, answer should be a non-leap year. Answer should be a non-leap year. In case if you are a student watching this video, in case if you want to know the details about our online course, we have a CAT course where 4,000 plus videos are there. The content will keep on getting added. Total number of learning hours is 800 plus amazing learning hours. Total number of tests that we plan to give to any enrolled student, it is 750 plus. We have added another 150 plus tests yesterday night. All the enrolled students, kindly check it out in your portal. 150 plus tests are added yesterday. Enrolled student, 150 plus tests. How many ebooks we will give? 80 plus ebooks we will give. CAT is considered to be the hottest selling course right of ours. And if you are preparing for CAT, any other exams that you can prepare, bank examination, 2000 plus videos are there, 500 plus learning hours. Number of tests a student will get is 600. Number of ebooks will be 126 plus. Staff selection commission, 2700 plus videos are there. There are certain topics in advanced mathematics which are little extensively asked in SSC but not asked in bank examination. 600 plus learning hours are there. 600 plus tests, 140 plus ebooks. In case if you are a student planning to write placement examinations, 1500 plus, 400 plus, 500 plus and 76 plus. This slide talks about the number of videos a student will get once you purchase the course. These all our course will be a combination of live plus pre-recorded. Live plus pre-recorded. The course will be a combination of live plus pre-recorded. In case if you want to go for topic wise courses, we have number system course, arithmetic course, algebra course, modern maths course, geometry and mensuration course, LRDI course and verbal ability course. Number system course, total number of learning hours are 140 plus. Every course that we give is a combination of learning hours, tests and ebooks, so that the 360 degrees learning will happen. Arithmetic, it is 120 plus hours. In this entire April month, I will take a lot of classes to cover two topics, that will be arithmetic and algebra. Hopefully by April end or May first week, we will be done with arithmetic and algebra. Then we will start with the most important topic, that is geometry and mensuration. These are the number of hours. All the live classes of that particular topic will be uploaded in the students portal. We have the courses available on 1 month, 3 months, 6 months and 12 months. In case if you want to join, you can always WhatsApp this number to know more about the course details. We are having a lot of extra sessions early in the morning and late in the night. Early in the morning we will have our session at around 6:15 and we will do the session till 7:30. Night we will have a session at 10:30 and we will do it till 11:30. Thanks a lot for attending this class. I hope these extra academic initiative of Anil Nair classes will help you to spend more time with me in terms of learning concepts beyond our schedule. Thanks a lot. With love, Anil Nair. Thank you.